In this lecture, we will discuss about relational algebra operations. So in the previous lecture, we have discussed about some of the relational algebra operations such as select, projection, union, set difference. Like these operations we have discussed in the previous lecture. In this lecture, we will discuss about join operation in relational algebra. A join operation pairs two tuples from different relations if and only if a given join condition is satisfied. A join is a combination of Cartesian product followed by a selection process. Join is denoted by the symbol bouty. Two types of joins are there: inner join and outer join. Inner join included only those tuples with matching attributes and the rest are discarded. These are the types available in inner join, that is theta join, echo join, and natural join. The outer join includes all the tuples from the participating relations. It won't check whether the condition satisfies or not. There are three types in outer join. One is left outer join, then right outer join, then full outer join. The inner join, first we will discuss about theta join. It combines tuples from different relations provided they satisfy the theta condition. The notation given for the inner join for theta inner join is relation 1 bouty, then theta, then relation 2. The theta represent the conditions such as equal to, less than, greater than, less than equal to, greater than equal to, etc. For example, we are having two tables here. One is student table, another one is subject table. The student table has the attributes student ID, name, and standard, and the subject has the attributes class and subject. Here, what I want to do is, I want to perform the inner join, that is inner theta join. The student dot std equal to subject dot class of subject. The meaning is, we are going to relate the standard from student table and class from the subject table. So if the standard from the student table and the class from the subject table is equal, means we have to produce the output as all the rows which are all equals the standard and class. You see here in the student table, the standards are 10 and 11. The 10 and 11 of the standard is also mentioned in the class 10, 11 in the subject table. So those things will be mentioned in the output. So 1001 Viswa, the standard 10, class 10, max will be included. Again for Viswa, physics will be included because the standard 10 has the class of 10 and the subject has max and physics. For Suganya also, she belongs to standard 11 and it is equal to the class 11 in the subject table. The subject has two subjects. One is chemistry and biology that has been mentioned here. The next is echo join and natural join. That is what we are going to discuss in the inner join. The echo join means when theta join usually uses only equality comparison operation, it is said to be echo join. That is what we have discussed previously. Here we will discuss about natural join, which does not use any comparison operator. The set of tuples of all combinations in R and S, that is R is a table, S is a table, that are equal on their common attribute names. We can perform a natural join only if there is at least one common attribute that exists between two relations. Here, the two relations are specialization and coordinator. What they are mentioning for natural join, at least one common attribute that exists between two relations. In specialization, it has three attributes: student ID, specialization, and department. In the coordinator relation, it is having two attributes: department and head. One common attribute mentioned in both the specialization and coordinator table is department. So we have to perform the join based on that. So the department will be mentioned first, then student ID from the specialization table, then head. So all these things will be combined. So it will be having CSE, department CSE, and the student ID 1001, and the specialization will be mentioned as cyber, and the head will be mentioned as Raman, which is from the coordinator table. So, and the second row will be mentioned with the department ECE, student ID will be mentioned with 1002, and specialization will be mentioned with robotics, and health will be mentioned with Lakshman. And outer join, left outer join. So the notation will be mentioned with the bouty. The bouty will be opened the left side little bit. So two tables are here. One is R, another one is S. Here all the tuples from the left relation are matching with the right relation are included. The meaning is we are having two tables here. One is specializations, another one is coordinator. Specializations has two attributes. One is SID, another one is specialize. Coordinator table has two attributes, SID and head. So now what the left outer join speaks is all the tuples from the left relation will be included. All the data from the left relation will be included, and the matching tuple in the right relations will be included. So you can see here SID is the common attribute here. In the SID of the specialization, it has 1001 and 1002. So that is mentioned here, and the specialization table, the specialization attribute that is that contains cyber and robotics, that will be included. In the right hand side, the SID, it contains only 1001. 1002 is not present. In spite of that, it contains 1003. So we cannot include 1003 here because the only thing equal is 1001. So we are using 1001 as a SID in the right hand side table, and the head will be mentioned as Raman. Lakshman will not be included because he contains the SID of 1003. This is what left outer join. Then in the right outer join, the notation bouty will be opened little bit in the right hand side. So there are two tables here. One is R, another one is S. The name of R is specializations and coordinator S is coordinator. You can see here the right hand side table will be included fully, 1001 and 1003, along with the head Raman and Lakshman. The left hand side, only the data which is equal to right hand side will be included. Here 1001 is the data equal, that is 1001 SID is equal to 1001 SID which is present in the right hand side. That will be included with the data cyber, but 1002 will not be included because we should have 1003 in the left hand side. Okay, but 1003 is not present. That's why it is mentioned with hyphen. This is what right outer join. The next thing is full outer join. Full outer join is the combination of both the left outer join and the right outer join. Okay, first left outer join will be performed. After that, right outer join will be performed. The combination of left and right outer join will be mentioned as the full outer join. In the notation, both the left hand side and the right hand side of the bouty, it will be opened little bit. Okay, so all the tuples from both participating relations are included in the full outer join. So when I want to summarize this lecture, what are all the things we discussed? We discussed about joins. There are two types of joins. One is inner join, another one is outer join. So inner join contains theta join, equijoin and natural join. Outer join contains left outer join, right outer join and full outer join. So I hope you have understood the concept of joins in relational algebra. So we will meet in the next lecture. Thank you.